What is going on? Just finished recording the text field episode, and I wanted to do an intermission. We're gonna do an intermission every now and then. Totally optional to watch. We're not really gonna be changing anything, or actually, we're not gonna be changing anything at all. If we do change something, we're not gonna keep it. What this is just gonna be is we're going to kind of talk about uh, what we're going to do in future episodes, what's going to be changed, what's not going to be changed, answer any questions. Um, there was a question about 3D, and we're going to cover that in this episode. There was also a question about uh, like microphone loudness, and it's totally because right before I started uh, these tutorial videos, my mic broke actually, and then I was like, oh, I'm just gonna use my gaming mic that I use on the Xbox. Totally good. Um, it was a prize from Windows, the Dream Play Build or Play Dream Build or some crap like that competition, and I got those, and they work perfectly good on Xbox, but do not work very good at recording videos because it is uh, auxiliary, and auxiliary mics just they suck. So right now I'm just recording on my webcam, which is okay. It works. It just picks up audio all around the house. That's why every now and then you hear kids running around or movies playing or the kids fighting or whatever. You hear just about everything, and that's the reason why. I'll get a better mic sometime later, but right now I'm not too heavily worried about it. So, to get on to the other question, for 3D, I'm just going to lay it out straight. And a lot of people are going to tell you differently. And honestly, everybody has their own opinion on how it works. But it all comes down to this. Uh, if you're using lightweight Java game library, if you're using OpenGL in general, and that's what you're drawing with, regardless of whether you're making a 2D game or 2D engine or 3D game, 3D engine, 2.5D, I don't care what it is. You are drawing in three-dimensional space, regardless. Um, and I will actually show you what I mean by this. I don't know why I have Peckerhead open. So down inside of the resources folder, I'll open up the vertex shader. If you notice, GL position is the position that OpenGL uses to draw their vertices. And we're using we're making a two-dimensional engine. Right now we're only doing GUI right now. We are not drawing in world space. Or we're not drawing the actual game window thing, whatever you want to call it. We're not doing any of that stuff yet. Right now, we're just strictly working on the GUI end to get the interface ready somewhat to be able to interact with these objects and to make it easier to build our game. Once we get into actually drawing what's in our world, uh, we will touch bases on this a little bit more, because right now we don't have rotation, we don't have any of that stuff because we're working in GUI space. There's no point in rotating a GUI. So I have not covered any of that yet. We haven't done more of the matrices yet. Right now we're just using an orthographic projection matrix, which we will continue to use, but currently that's the only matrix that we're passing into the shader. We're also going to need a view matrix, which is the matrix for the camera. And we are most likely going to be using a transformation matrix. Just because if we do add rotation, because like I said, I don't know exactly if we're going to add that or not. Possibly, knowing me, I like to add everything. It's, I don't know. It's an iffy subject because rotation really isn't 100% needed for everything. So if adding rotation, and if you're not actually rotating anything in the game, say you're just rotating your player, well, guess what? If you add rotation just to rotate your player, you are eating up so much memory because the entire world is accessing this rotation when it's not even needed. Nothing is rotating. So, like, I don't know. It's an iffy thing. But back to what we were talking about. This right here is what I'm passing in for the world position. If you notice, we're in 2D, so I'm passing in a vector 2 position. Well, that may make you think, oh, well, we're only working in 2D space. No. This is what we're actually passing to OpenGL. It's a vector 4. This is your Z position. The only reason why it looks flat is because of the projection matrix, because we're making it look flat. We have no Z value because we're always passing in 0. But if you notice, we're working in three-dimensional space. So we're actually drawing 3D even though it's a 2D game, because that's just how it works. Whenever OpenGL renders it, it renders it in three-dimensional space. So, honestly, the only thing that makes it two-dimensional with no Z value is this little guy right there. There is what makes a 2D game and what makes a 3D game. That's it. Even if the projection matrix, say let's take projection matrix out of the equation, and we always pass in a regular projection matrix. Then this would be flat, and if we say, we pass in an x value and this changes, then you would see the difference between flat and not flat. And that's honestly it. If I honestly wanted to draw a 3D object, let's say I wanted to draw a cube in the world. If I change this right here to a vector 3, and I put right here, actually let's say I get rid of all this right here. I'm not too worried about screen position or pixel size, whatever. Let's say we're drawing in the world, because in the world it would honestly just be position. But it would say vector 4 position, comma 1, because this would be a vector 3. So it would look like vec4 position 1. And I just pass that in as this right here. So I have that changed. I have this changed up here. The only thing that's different is this mesh data. So if I had three-dimensional mesh data, say a cube, and that's what I created for the mesh, and then I say mesh.render, it's going to be passed to this vertex shader as a vector 3, and it's going to draw it in 3D space as a cube. Now you're not going to be able to tell that it's a cube. It's going to look a little wonky, very flat. And the reason for that is there's no shading. So you would see like the front, and let's say the cube's over here, you would kind of see like an angle or whatever, but it'd be very, very flat. So yeah, that's really it. I mean, that's how you draw in 3D. It's very, very simple. And if I open up my 3D engine, Peckerhead, now my setup is a lot different in here because, like I said, anytime I make an engine, it's gonna be different because every time I make an engine, I make tweaks. I make performance enhancements. I say, hey, I don't want this anymore, but I want this. And I just kind of merge things together. And so it's going to look a lot different. For instance, here's my 3D mesh class for my 3D engine. It looks very similar, except for the bind and unbind. And I have mesh.find. And I store everything in a raw mesh. A raw mesh is basically just all the raw mesh data, like vertices, UVs, normals, stuff like that. That's all a raw mesh is. And as you can see here, I literally just pass in the arrays. And then all I do is I just set it in there. And once I pass it in here, I do basically the same thing that we do before. And whenever I'm binding the vertices array, I'm binding vertices, UVs, normals. That's what these are. And that's how I store them uh, whenever I import them in. So I also have a memory class. This holds all of my VBOs and all of my VAOs for the engine, for the game, blah de blah. And whenever I load a mesh, I pass in all this data, and then here's where I store these values. So I store vertices in slot 0, 3, because it's vector 3. Store this in 1, 2, because it's vector 2 of UVs. And slot 2, 3 values, because it's a vector 3 normals. So just like how we do in the 2D engine that we're doing now, it's all very similar. It's the exact same thing, except for in the 2D game, I don't need normals. I don't really care about normals. I don't care which direction the face is facing because we're not using projective lighting and all this other crap. We don't need shading and all that. So let's see here. And this is store an attribute list. It's the exact same thing we do in our 2D engine. Let's see if I can pull this up in our 2D engine. Mesh class. This data right here. That's all it is. So I'll copy that. Come back over to my memory class. I'll come back over here. Look, exactly the same thing. We're doing the exact same thing. Except for right here, for some odd reason, whenever we made the mesh class, I put vertices.length divided by theory. I don't know why I did that. It's just 3. That's it. We don't need vertices.length. That's stupid. But if you look, it is literally exactly the same thing. And this is a 3D engine. This is strictly for 3D. No 2D about it besides GUI. But yeah, that's all it does in the store and attribute. So instead of doing it individually like we are right here, and the only reason why we're doing this is because all we need is vertices and UVs. So there's no point in creating an entirely different function for it. And right here, I'm not creating a GL vertex attribute pointer. So it would be right here. We would change this value. We're storing this in 0. So if we're making a 3D engine or we actually cared which attribute number it is, or if we're not doing it in order or whatever, we would make this a 1 and then normals a 2. The only reason why I don't put it right here is because I have it in order. This is stored in 0, so this I put next, so obviously it's going to be in 1. So if you know the order, you don't really need a pointer for it. So there's no point in doing all that. So that's why this UVs doesn't have it. But yeah, so it's just a function that sets everything in there. So then all I have to do is just call store and attributes, pointer number, what size, and all that. So it just does it for me. So there's a lot more functions that handles that versus in our 2D engine that we're making right now, everything is handled inside of that one mesh class. And in my 3D engine, there's 3 different classes that hold the data for a mesh, which is seems kind of extensive, but whenever you're doing uh, whenever you're doing all the things that you need to do for 3D, then it's kind of a good idea to have that data stored wherever you can access it. Because one thing may access it in game, one thing may access it outside of the game, one thing may just be static information. So you kind of have to separate that stuff up wherever you can do it. So now that we talked about uh, the differences between 2D and 3D, which I literally just showed you is jack. It's the exact same thing, just not passing in a vector 3. We're passing in a vector 2. That's it. There's absolutely no difference. Uh, Another thing is he also mentioned that there's a lot of lightweight Java game library 2 videos out there, which there is. I mean, I've been through a lot of them. I watch tons of tutorial videos, and it's not really because I'm like, ooh, I need to take this guy's stuff. or anything like that. It's pretty much just learning the exact same thing that I already know. But what's good about watching videos of people programming is everybody programs in their own way. So, watching a bunch of tutorials, it kind of shows you ways of doing things that you normally wouldn't do, or it didn't click in your head. Oh, hey, this is a lot easier. This is more efficient. Stuff like that. So I watch a lot of tutorials and I learn a lot, even though I've been programming for like literally my entire life. I learn stuff all the time just from guys messing around, you know? And that's how I actually learned, well, not really learned, but that's how I got. Doo-doo-doo. Did I put it in shade? Okay, I'm in logic. That's how I got these bad guys right here. These set uniforms. I actually got that from another tutorial. I actually did it a complete different way, and it was actually a little bit more difficult to do. And I was watching tutorial videos one day and eating popcorn, obviously, because why not? Feet kicked up, just chilling. And we got to the shader part, and he started separating things into categories, and he was passing in the uniform names and the data that you want to pass into it. And I'm like, why in the world did I not do that before? Because it's so much easier. And I believe I got it from, it was either Thin Matrix or it was the Benny box. And I believe, not 100% positive, but I truly believe that both of those guys are doing tutorials in lightweight Java game library 2. And that's the whole reason why I bring this up. Is all their stuff is in lightweight Java game library 2. We are using lightweight Java game library 3. And you obviously see me doing these things that I've, came across in lightweight Java game library 2. There is almost no difference between the two. Mainly, the only things you need to get around is uh, lwjgl 3 got rid of a lot of things. They got rid of like a lot of their math classes. They got rid of their keyboard class. So it's not really adding things or changing things. It's they remove that stuff. And it's because you don't really need it. A lot of people just like import joggle classes or whatever, and it's the exact same thing because it's just a custom class. That's all it is. I mean, we make them. We've already made we've still got some functions to add to it, but we've already created some of these things, which you can also find in the joggle class. But I like to do everything uh, myself. I don't like to import libraries or anything like that, and I'm sure you've noticed that. But so that's a difference. And how you show windows. And besides that, a lot of it is identical. like, they didn't really change the OpenGL side of things. I mean, they did a little bit, but not really. There's not that big of a difference at all. So as long as you know how to open a window, access the mouse, stuff like that, the GLFW side of things. If you know that, which I have already taught you in this series already, you can go out and follow any lightweight Java Game Library 2 tutorial and just bust it out. And it will work perfect every time. Uh, so if you want to create a 3D engine, let's say you're not doing a 3D or you're not doing a 2D game. And the only reason why you're following this tutorial or watching this tutorial is because you only want to do 3D, but my tutorial is the most up to date, which it is. There's a lot of tutorials, like I mentioned before. The Thin Matrix made it, a few years ago. It's Lightweight Java Game Library 2. Some of it is, you know, a little bit out of date, but that's just because it's Lightweight Java Game Library 2. That's the only reason why. Um, the Benny Box, like 7 or 8 years ago, he made his tutorial. So it's a little bit out of date, but they're still great tutorials. And I mention those two because they're absolutely great. They have a very long tutorial series. They didn't give up. They went boom straight through. The Benny Box does physics, um, uh, physics like collision interaction, all kinds of good stuff. Um, Thin Matrix does skeletal animations, um, does shadow mapping, which I believe Benny Box does as well. Does all kinds of cool stuff. But Thin Matrix doesn't do any of the collision side. My tutorial will be, or this series will not be covering, at least for now, the next couple years, because I plan on doing this for quite some time, just updating and just making it better. Will not be doing any of the 3D side. I will not be covering any of that stuff. And it would be a waste of time and out of the scope of this tutorial to do something in 3D. So that's why I kind of point you in that direction. And I mean, don't get me wrong. You can watch this video to learn the GLFW side and kind of how I do things and kind of go through there. And like I said, right now we're working on the GUI side. So yes, it will help you in the end. So if you want to watch the GUI side of things, just to make the engine itself, like the engine editor, then great. You'll have the editor set up and boom, set up and ready for 3D. And then you just start the 3D side from there. But the most difficult part is since, or actually, I'll go with most people think that once you render 3D, you can make 3D games. That's totally not how it works. Yeah, you can render something in 3D, and like I showed you, it's very simple. You basically change a couple things and then boom, you're in 3D. It's it's super easy. But that's just a render in 3D. You still have shading, bump mapping, height mapping. Uh, you still have like skeletal animations. You have three-dimensional physics. There's all kinds of things that go into a 3D game. It's not just rendering. Like there is a lot of stuff that has to be done, and we are not going to be covering stuff like that because we're doing 2D. I have no need in a 2D game for a skeletal animation system or height mapping or any of this crazy stuff because we're in 2D. We're just drawing quads on the screen. So I highly suggest going to Thin Matrix because he is one of the newer people. He created a tutorial after the Benny Box, and if you want to learn 3D physics, definitely go to the Benny Box. He's a good dude. But yeah, I would honestly, in my own opinion, check out Thin Matrix's tutorial and do the GLFW stuff and follow along with the 3D code that he uses because he covers a lot of stuff and it will definitely help you and it will not hurt you that you're using LWJGL3 and they're using 2 because once you get past the window crap and the things that you need from GLFW, then it's like I said, exactly the same. Let's open up application really quick. And I'll close some of this stuff. Now let me open up. Wait, no, because this is LWJGL3 too. Okay. So this is what our GLFW stuff is. That stuff right there is 3 our window size callbacks, our mouse, and guess what? That's it. This is OpenGL stuff. Has nothing to do with GLFW, so it works with both version 2 and 3. Same thing with this stuff right here. And so, like I said, it's honestly almost identical. Works with both versions. All this stuff, all of our custom stuff works perfectly fine. This right here is a GLFW thing. So instead of putting while whatever in the crap 2 has, I can't remember, it's been so long since I've used it. So instead of putting that, you would just put this right here. GLFW pull events, that of course is GLFW. Same thing with this. But this works with both versions. But besides, this, this, our window callbacks, and initializing GLFW, besides that, really that's the only crap you're worrying about. And that's the whole reason why people are like, oh, well, I don't want to watch this tutorial because it's lightweight Java game library 2. Well, that right there is the difference. That's all you're looking at. Everything else in here, I'm not using GLFW for crap. Everything is this right here. OpenGL. Nothing GLFW. So even if I go through all these, none of these classes are going to have GLFW in it. They're all interchangeable. Has nothing to do with the specific version of lightweight Java game library I'm using. So just kind of think about that. Don't worry so much about versions or, not seeing documentation on it or whatever. Because I've taught you the differences between the two. That's really it. What I've already showed you, what we did in like the first like 2 or 3 episodes. Like that's the GLFW stuff. That's it. So don't let that hold you back. Watch some good tutorials and do your whole 3D thing. Don't worry about this whole 2D stuff if you're not making a three-dimensional engine. But you can always watch for the editor because I believe I am the only one uh, on YouTube doing a full-on game engine editor that is fully interactable, doing all this stuff like the actual editor stuff. So yeah, be my guest. I mean, if you want to learn all this stuff, that's great. Implement it into your own engine. But as for rendering the world, like I said, we haven't gotten there yet, but we will not be covering 3D, the actual other 3D stuff, like I mentioned before. But I hope this doesn't discourage you or anything. And, just do your thing. Don't get held back on the stupid petty stuff. Just hit it hard, and I honestly wish you the best of luck. So I will see you next week, hopefully. As for everybody that's doing the 2D stuff, I will hopefully see you next week. All right. Well, have a good week, guys, and I will see you next week where we will be working on interacting with floats and maybe possibly integers. And then after that, our vector stuff and rect stuff, and then we will possibly, after those 2 episodes, go into rendering our scene. All right. Well, I'll see you then.